So taking a look at what we have here, we have looking at the middle, so we'll line the middles up where they're supposed to be. Let's see where these edges are in comparison with where we want it. So this yellow is supposed to be here, this white is supposed to be here, and this is supposed to be here, this is supposed to be here. So in this particular situation, we have this that needs to go here. It's 90 degrees off of where it needs to be. This is 180 degrees, 180 degrees, and this is 90 degrees. So turning it around here, my overall strategy is I want everything 180 degrees. It doesn't matter if they're completely lined up, but as long as they're within 180 degrees, then we can use that. So how are we going to do that? I promised you layer by layer, and I'm going to deliver. So what I want to do is I want to somehow get this to here and this to here. I want to swap these two sides. The reason that I want to do that is when I swap this here, this red one is going to be 180 degrees where we want it to be, and this is going to be within 180 degrees as well. So when thinking about it, we actually have an algorithm that can swap middles, right? We encounter that with the 3x3x4, 3x3x5, and in the 4x4x5, and that's where we do the 2u. I'm sorry, 2r, u, 2r, u, 2r, 2u, 2r, 2u, that algorithm. What that's going to do is it'll put this to here and this to here, but what it'll also do is it's going to rotate this middle by 180 degrees. So it's just a question of predicting where we're going to end up. Plus we're going to create a parity situation here and here, which is okay because as long as we move with this axis of rotation, the next time we can fix it. And we're going to be doing these middle swaps, either right angle middle swaps or 180 middle swaps to get that back. But if I do that, red is going to be here, yellow is going to be here, these aren't going to be touched, and this is going to rotate around. So the yellow middle is going to be here, matching up with this, and the red is going to be here. So you're going to see that the yellow and the red are going to be solved, whereas here, this is going to stay the same, this is going to stay the same, but white is going to be here, and purple is going to be here. So this is actually going to solve this is predictably going to, well, this might actually solve it. So let's see what happens. So 2r, u, 2r, u, 2r, 2u, 2r, 2u, 2r, u, 2r, ui, 2r. All right, so we have our parity here, and this did what I predicted. It basically put the yellow here, the red here, the white here, and the blue here. So now the question is, how am I going to deal with this? We'll put these back in the middles, back where they're supposed to be. But how am I going to deal with this parity situation? Well, this is kind of what you might think the limitation of the layer by layer. It's not impossible, but it just takes a couple of moves and it takes some concentration. What I'm going to do is solve this parity situation, which is going to rotate. I'm going to flip these two centers. This is going to rotate this around and effectively put none of them where they're supposed to be, but as long as they're within 180 degrees, I can actually fix it. If your goal is to solve these cubes as fast as you can and as efficiently as you can, then this method isn't obviously going to work for you. But if your goal is like mine, to do minimization or unification of algorithms, where you do minimal amount of algorithms to solve maximum amount of cubes, then you can do it this way. It's not as efficient at times, and it could be slower, but for me it's a lot more fun to work out a way of solving things, memorizing as few algorithms as possible. I don't want to make it to where all of my cubes have all different strategies to solve. I don't know if if that makes much sense, but that's just how I look at it. So what I'm going to do is swap these two middles to keep everything at 180 degrees, and that's going to be my particular algorithm for that. 2r, 2u, 2r, 2u, 2r, 2u. We fixed this parity, so I still have this layer. But what happened is this is still good, but these got swapped. These got rotated. But we know how to deal with that, right? We know how to fix that. I'm actually going to put these in the centers that they're supposed to be. And we fix that with that funky algorithm of ours, the URF'd. I actually suspected I may have to do it twice, but I don't. I just have to do it once. I just had to swap one, and then everything was solved, but to get out of the parity, I just swapped two middles, which kept two solved but didn't do the others. So we'll just go ahead and do the algorithm to solve this part. So that's going to be U R F U R prime F. The other one was an F prime. And then split it here, split it there. F prime R U prime F R prime and D. And that should have done it, and it did. So once again, those are solved, and everything is where it's supposed to be, and we just have to solve these centers, and that's how we get out of that particular situation. So here's another situation that you might run into, another possibility. This is where one of them is where it's supposed to be. In this case, it's the yellow one, and none of the others are. This is actually this is the easiest one, because all you have to do is do the same middle rotating algorithm that you did with the 3x3. When you're at this point in the layer method of the Rubik's Cube 3x3, if you had one that was lined up to move this other one to rotate it around, you just do that algorithm of R. Well, you do R U R prime U R 2U R prime. And what that does is this is going to rotate these around, so this is still where it needs to be. Don't have the purple in there yet, so we do it again. And then it's rotated in. So if you see that, if you just see that just one is where it needs to be, then just solve it like a regular 3x3. These will all be in position, solve your corners, and you're done. So there's no issues with that. That's actually the easiest of all the possible situations.